Alright, so I just want to take one more minute and look at one more example dealing with momentum and impulse. And so let's look at this one, where a brick is being dropped on a glass table. I want to make sure that we looked at the impulse part of it as well. So we've got a brick that's being dropped onto a glass table, and hopefully not going to break it, because that would be a mess. So A, what is the magnitude and direction of the impulse necessary to stop the brick? Okay, so impulse is, we said in class, J, which is equal to the change in the momentum. Okay, so we're assuming that in the end, if we're stopping the brick, that our final momentum is going to be 0. So it's the momentum final minus the momentum initial, right? So we're going to find that change. The final momentum will be 0. Okay, so now I got to find the initial momentum. The initial momentum is going to be its mass times its velocity, right? So it's being dropped from a height of 20 centimeters, right? So I now need to find the speed because I know the mass, so 0 minus 1.5 times the velocity, but how fast is it going when it hits the table? So in order to do that, I'm going to need my kinematics, right? I know, let's write down the information that we have. Position, initial velocity, final velocity, acceleration, and time. I know it's traveling at an acceleration of negative 9.81 meters per second squared. Initially, it's being dropped, so I'm going to say that the initial velocity is 0, and then I know that the displacement is negative 20 centimeters, or negative 0.20 meters. So with those three pieces of information, I should be able to find the velocity as it hits the table. Okay, there's an equation that is v squared equals v naught squared plus 2ax. Alright, so let's solve for the final velocity. So 0 squared plus 2 times negative 9.81 times x, which is negative 0.2. So let's do 2 times negative 9.81 times negative 0.2, and that will be 3.924, which is equal to v squared sorry. And so now let's take the square root of the answer, which will be 1.98. So the velocity will be 1.98 meters per second as it hits, so we can now put that in, 1.98, multiply that by 1.5, and I get a change in momentum of negative 2.97. So the impulse is negative 2.97. Okay? And then impulse, of course, is in kilogram meters per second. That's the units. Okay? So that is A, and obviously in this case it's got to be an impulse negative. It's got to be negative because the momentum initially was, I guess we could say if the initial momentum was going down and we called that positive here, right, that means that the change in momentum has to be in the opposite direction, which means therefore going up. Okay? Letter B, if the tabletop doesn't shatter and stops the brick in 0.1 seconds, what's the average force? Well, that's where we can then take the change in momentum is equal to the force times the time, right? The momentum is going to be the same no matter what, but if our time is 0.01 seconds, that means that negative 2.97 is going to be equal to the force times 0.01 divided by 0.01, and the force is negative 297 newtons. So that would be the force, is 297 newtons. All right. Now, what is the average force that the brick exerts on the tabletop? Well, Newton's third law says that if object A exerts a force on object B, then object B exerts the same force in the opposite direction on object A, which means that if the glass exerts a force of 297 newtons on the brick has to exert the same force on the tabletop. And so therefore 297 newtons, or approximately 300 newtons. The brick obviously is pushing down, the table is pushing up. Now we did go a little bit against convention here because we initially said that the change in momentum was negative, which means that I was calling up negative and down positive. And that's okay, as long as you're clear in your convention and that you stick to whatever you started with. So I hope that's okay. I hope that made sense, looking at something with the impulse. And good luck on your homework assignment.